Okay, we'll start. Good morning, everybody. So today we're gonna walk you through how can we apply what we learned from Robo-vision 1 with Dr. Uwais, and what we are gonna do today. We have two main objectives. First thing we'll do is we'll have a line, as you can see on the camera here. This line will try to read the angle it makes. So if we assume that the robot is on here, so what we need to read is this angle, so that we can have the robot turn along this angle. So the way we're going to do that is using Python and a library called opencv. So opencv is a very useful library we can use in Python that allows us to do all sorts of image processing. And yeah, so the first code we're going to show you here is this one, where basically we're taking the image from the camera. And for the camera, by the way, I'm using an app called Camo that you can connect to your phone and your laptop with, and use your phone as a webcam. So this image is coming from my phone. And yeah, so first thing you need to do is do cv.video capture, which basically captures the image from the camera. But we have different cameras maybe connected to your phone. Usually you have your webcam and maybe the phone camera, so you need to choose the device, and that's this parameter right here. So it's usually, I'd say maybe it will be 1 for you, depending. You can try different parameters and see. It starts from 0 to whatever, and then we'll take we'll keep taking frames from the camera, and the way we do it is we basically analyze each frame alone, and we'll display this frame. So that will make the video basically. So right here we're working with a color space called HSV, which stands for hue, saturation, and value. So it's like the RGB. So you have it basically you have to decide a value for the hue, saturation, and the value it gives you a certain color. So what we're trying to do is we want to eliminate all the colors that we are not interested in. So for this case right here, we want to eliminate anything that's not black, because that's what we want here. We want to read the black, and we want to generate what's called a binary image. What a binary image is, it's basically the image is comprised of matrix. So the binary image is basically zeros, anything that you're not interested in, or anything that's not inside the color range you have, it will be 0, and anything that you want will be 1 basically. So that makes it way easier for us to work with the image and the image processing and stuff like that. So first of all, we take the image and transform it to the HSV color frame, and then we define our range for the image. So the way we get these values is we have also a very handy program here in the notebook. It's down there, yeah, this one, where basically it can take an image. For this, I just took a screenshot of the image from the camera. I take a screenshot, and the way it works is you have when you run it and it reads the image, it gives you this GUI, and you can adjust. Okay, and you can adjust these sliders in order to satisfy what you need. So try to adjust these sliders until you get only the black in the image. So maybe something like that. I think. Actually, wait, hold on. Let me check the values I had. Yeah, so the values I had was 0, 0, 0, and 179.255 and 74. 179.255 and 74. And 74, I think it's this one. Yes, so you can see here I'm basically eliminating anything in the image that's not black. So anything that's not my line is being black here. So this is how I'm like detecting only what I need. And when you do that, you'll get the values. You put it in these arrays right here, and yeah, then we do a mask. So what a mask is basically I'm basically doing what I said, where like I'm eliminating anything that's outside my range. So I have zeros everywhere else and like values that inside the things I need, are like ones basically. And then this is like to the res is to show it in its original color. This is just an extra step. And then we do something called edge detection. So if you see here, if I run this program, so this is what the thing is seeing. So this is the black and white image that's coming out of the mask. So as you can see here, anything that's not that I'm not interested in is black, which is 0, and what I'm interested in is 1, which is the white thing. So now I have my line here. What I can do is something called edge detection, which is an algorithm that basically just determines the edges of the shape I have. So I'll have a line here, and similar stuff. So this is what you can see in here. So you can see here I have my lines for the line, the actual line, like in the black tape here. So I'm detecting the lines of the edges of the black tape, so that later on we'll do something called the Hoff algorithm, and the Hoff algorithm will detect the lines itself and the angle of the line. So now that I got my edged image, I can go to my next code right here, which applies this Hoff algorithm. So the way Hoff algorithm works is basically, it's a complicated way, but it basically detects all of like each point and the intersection of each point with other points. So basically it detects correlations between points, and those correlations, you'll get a line from it. This line will have two values. One is called rho. Rho is like how far away the line is from the center point, and the other one is called theta, which is the angle of the line itself, which is what we're interested in here. So what we do here is, like, again, we read the frame, we're doing HSV, the mask, and then the edge detection, everything else, and then we'll apply the function called Hoff lines. So the Hoff lines takes, first of all, the image itself, the image we'll want to apply Hoff lines to. I think, hold on, I can't remember this. Rho and theta, the resolution of rho and theta. So like how like the approximation of it basically. So it's gonna be like, for example, here rho will be either 1 or 2. If I want to be a bit more accurate, I can make the resolution 0.5. So it can be either 1.5 or 2. So if you want, that's for accuracy. And for theta, we're doing it a resolution of 1 degree. So pi over 180, because everything here works with radian. So everything here works with radian. So pi over 180 will give you like the value of 1 degree in radian, basically. And then we'll have this here is it's like the threshold. So as I said, like Hoff algorithm works by like finding correlations between lines, and then like each like point that like cross it, like that correlates with another point, that's called an intersection. So for me to determine what the line is, I need to have a certain points of a certain number of intersections. So this is what this threshold is. So if I increase this threshold, I have to have a very clear line that's like also like has a lot of correlations to determine that it is a line. If I want to detect anything that closely resembles a line, maybe I need to decrease the threshold. And then the other parameters don't need to worry about. Anyways, so we'll have the threshold. The threshold controls what I deem a line and what I don't deem a line. And then we'll do is, right now all of the lines that are detected are saved in this lines array. So the lines array has rows and the row and the theta for each line. So what I'm doing is first checking if I did find the line or not. So if I did find the line, I'll go through each line I have. I'll extract its row. I'll extract the theta, and I'm changing the theta because the theta, as we said, it's in rad. So I want to work in degrees because it's easier to understand a bit. So I changed it to degrees, and I'm printing it for us to see here. And then this is just some mathematical manipulation to extract the line and display it on the image itself. So if I run the code right now, you can see. Right now I have the threshold as very low, but I'm detecting a lot of lines. If I move the camera a bit here. Okay, so as you can see, I'm detecting the line. It's a bit hazy because of the line. The thing is not perfect. The line that I made is not perfect, but it's detecting the lines and it's detecting the angles. If we can see here in the printing, so you can see it's printing the angle, all of the angles that it's finding. Okay, what we can do to eliminate the angles we don't want, because like we don't want these angles, like the one we are on. So because like I know I'm on the line itself, the only angle I'm interested in is this line, is this angle right here. So we can just eliminate all of the angles that are higher than 175 degrees, or which means like it's straight, because like it's straight, 180 is like this as well. So if we do that, oh wait, I accidentally exited. Okay. Oh, the camera is not straight, is it? No. So we can do as well as like we can increase, like this can be 165 maybe, I think it's, yeah. So now I'm eliminating all of the other lines. You can see this is just because of the tape is, I'm very bad at placing tape apparently, but I'm detecting those angles. Something you can do if you want, you can also like enhance it. Of course this will not be the track will be actually made good. Don't worry about it, but you can just basically get the average of those angles, and you can take this as your own angle and stuff like that. This is your guys' job. What we're trying to teach you here is basically just how to start working with these kind of things. So that's it. That's how we managed to get like angles and detect lines in an image. It's not that difficult. As you can see, it's mostly just functions that are already there and made for you. You don't need to worry about it that much. What you do need to worry about is how can you filter the data, how can you only get the data that you're interested in, and how can you translate this data into movement in the robot, how can you, like, you know, perfect everything else, basically. So that's our first objective done. We managed to find the lines in an image and get their angle. Now we'll do something called object detection. So if we assume I have an object, right? Okay, let me bring the camera here now. Like this rubber eraser thingy. Okay? Wait, you can't see the camera, can you? Okay, hold on. Like if we have this rubber eraser thingy. So I want my robot, like this will be one of the objectives inshallah next semester competition. We'll need you guys to basically have your robot follow our robot. We'll have like our own robot and it will have like maybe a plastic shell around it. That's a solid color for it to be easier to detect. And if my robot goes right, your robot should go right. If my robot goes left, your robot should also go left. So your robot's objective is to try to keep a close follow, or it's basically like a game of chase. You're trying to chase my robot. So the way we do that, it's also not that difficult. We have things called trackers in opencv, and trackers have many algorithms. Right now we're showing I think about 7 or 8. Well, all of these algorithms have different use cases. They are like some are better than others in some things, some are better than others in other things. This would be something you guys can try at home as well. But for example, so this is the code that basically just I'm taking the image, the video capture again, and then I'm just checking if I can actually open the video or not here, and then we'll do what's called the bounding box. First thing we'll need to do is we'll need to specify to the code what do you need to track. So it will open you a frame of the current thing that the camera is seeing, and it will ask you to basically, I'll show you. It's better to show. Oh wait, no, hold on. Need to change the video capture device. Okay. Hold on 1 second. It's sometimes. By the way, the code is this stuff here kind of iffy sometimes, so it can like crash a bit. So expect that. It's normal. But anyways, it should work now. Yeah. So you can see here it opens this frame. What you need to do is basically just try to put a bounding box on the object you want to follow. And then if I press enter, it will try its best to keep a track on this eraser. So if I move it to here, as you can see the box is moving with it. If I move it there, now it lost track because this algorithm is kind of slow. But if we try maybe a different algorithm, like I think maybe 7, no, 5. Oh no, 5 is not working. 4 is I think TLD. So this one, you can see the box is moving with it. Can lose track as well sometimes. Okay, it lost tracking again. I think there was one, I can't remember which one was that. Okay, yeah, this one is extremely slow. Also, keep in mind that I'm recording this session, so my laptop is not handling it as best as it could. We can try another algorithm. I think maybe 17. Yeah, the laptop is not dealing with it that much right now. But basically, yeah, so this is how you do tracking. So, we have a question. Yeah, you're just choosing from like algorithms that are already there. You're not doing anything from your own thing. So the thing you are going to be doing here is basically, so you can see, okay, this is whatever. So just to finish up, basically what you are going to have to do is you can get the coordinates of the bounding box from the algorithm itself. Like we can get the bounding box, and from the bounding box you can basically determine whether it's on the right, it's on the left, maybe it's smaller, that means that the robot is a bit further away, so maybe you need to move faster. If it's bigger, the robot is right in front of you, so maybe you need to slow down a bit. So you're just trying to extract the information you need from here and figure out how it works with your own robot, how to program it, how can you send this data to your robot as well. That's something we inshallah will talk about in the free days this Thursday, where we'll try to explain to you guys how do you, like, okay, I have this data right now on my laptop. How can I send this data to the Arduino, or in this case, our case, we'll be using what's called the ESP32. How can I send this data to the ESP32 so that it can react, it can move around, it can like turn or whatever. So we'll talk more about this in the free days, inshallah. But it's basically you're just sending the data most likely through Wi-Fi. You can send it through Bluetooth, but Wi-Fi is a bit faster as well. So yeah, I think that concludes all what we want to say today. But yeah.